Okay, so years ago, I had a student. His name was Steve. This isn't me. Hi, Steve. How you doing? And so this guy told me that he worked at a casino, and he even told me that sometimes they'll pull the dice off of a craps table and they'll roll them and test them to see if they're behaving the way they should. So let's just say Steve works at a craps table, and for some reason he thinks that a certain die is coming up 2 more often than it should. The number 2 is coming up more than it should. Okay, so his suspicion is that that particular number is coming up more than it should. All right, so that would be an alternative type of thing. And this again would be Steve's suspicion that that die is behaving strangely. And now you got to think about, okay, when you roll a die, there's 6 sides to it, right? We've had this type of question, we're talking about dice a lot. A particular number, such as 2, would be one number out of 6, wouldn't it? So doesn't he think that that number is coming up more than 1/6 of the time? That's the idea there. So he thinks that a particular number is coming up more than 1/6 of the time. That's his suspicion. And we go, well, okay, but let's assume that it's coming up 1/6 of the time like it's supposed to. All right? And by the way, 1/6 is a messy decimal. It's 0.1666666, about 17%. So that number should come up, about 1 out of every 6 times, but he thinks it's not. That's his suspicion, more than. And as we've been mentioning, that would be, again, considered an alternative hypothesis. His suspicion, more than. All right, so here's our test statistic. And again, if you were going to perform this test at the casino, you can pick whatever alpha you want. I've had difficulty finding out what alpha value is considered standard here. Let's just say, for the sake of argument, 3%. And again, that alpha value can be whatever the tester wants to use. But given the fact that the alternative is a greater than, we would say, okay, you think this die is behaving strangely? Prove it. We'll give you that upper tail 3%. Okay? And we'll give the rest of the bell curve to the null hypothesis, which I would remind you is the assumption it's a fair die, that number's coming up 1/6 of the time like it should, or close to 1/6, statistically close. All right? So anyway, if you got an upper tail of 3%, then the middle sliver is going to be 47%. These have to add up to 50%. We've had that discussion many times. You're tired of me saying that, but it is indeed true. That's an assumed skill that you still have. So anyway, a middle sliver of 47% is going to be closest to the 4699, and that's a z-score of 1.88. And it's on the positive side, greater than, positive. So if we get a z-score later on that's greater than that 1.88, we will reject the assumption that it's a fair die in favor of, no, it's acting suspiciously, as Steve suspects. All right, what do you do now? You go roll the die a bunch of times, and you see how often the number 2 comes up. And again, I'll remind you, if I've gotten away from this too much, we're testing a claim about the population of rolls, theoretically if you rolled forever, and we're going to test that with a sample of rolls, p hat, right? P hat is the percentage obtained from a sample. So if somebody goes and they roll the die 200 times, and that number comes up 42 times, which by the way is right at 21%. I want to remind you that that's about 17%. So 21% is a lot higher than 17, isn't it? A lot? Really? I don't know. 21 is higher than 17%. That die is guilty. That die is behaving strangely. Not necessarily. Put it into this rigorous statistical test to check. So 21% would be our p hat. This time the p, since it's a messy decimal, we need to put that in fraction form 1/6. Keep it as accurate as you can in your calculator. Type it in as 1/6. All right. Let's see, the p would be 1/6. So wouldn't q be 5/6? Those are messy decimals. And then the n is 200. You know, I struggle with it. How much can I hold your hand poking those in? Right now, I'm not supposed to hold your hand, and I'm not here, you know, how are we going to do this? Okay? So typing that in a calculator, I'm supposed to be a snob and say, you learned how to do things like that in college algebra, and that was a prerequisite. I don't like being snobby, but I don't know what to do, okay? I can't walk around the room and watch you poke it in, so I'll just tell you that should come out to be 1.644, something along those lines. Okay, and if we look at this picture, we would see that the 1.644 does not fall beyond the 1.88. It is not a z-score greater than 1.88. The point is, get this z-score and look at your rules and see whether or not to reject a null hypothesis. So you would hopefully look at this, say, you know what, yeah, 21 is higher than 17% roughly, but not significantly higher. It didn't exceed the statistical threshold here. And so I hope you would agree that there's not enough evidence to reject the null hypothesis. Okay, and so that should be our decision, would be to not reject the null hypothesis. And I think the question, let's look at the question, is there evidence to support Steve's suspicion? Here's Steve's suspicion. Was there evidence to support it? No. This is his suspicion out here. We didn't land out there. I don't know how else to say it. So, it's hard to look around the room and check you guys for understanding. I hope you're at home going, yeah, I get it. So, do not reject the null, and therefore there is not evidence to support Steve's suspicion. His suspicion was the alternative. There was not enough evidence to support that suspicion. Look at where you put the star. I always tell people, after you get your number, look at your picture and put the star up here, and then answer the question. Who won? Steve was the alternative. And there was not enough evidence to support that alternative hypothesis. Steve, in this example, was the ha. Okay? So anyway, speaking of the ha, one of the things I have to do whenever I want to click a link now is I have to go change this, and it's hardly worth it. You can quit watching. I don't know. This is hardly worth it. It's hardly worth the build-up. But we had something about the ho earlier. Now let's have something for the ha. And this is kind of old, but whatever. We're trying. I miss you. We could all be dancing here together. All right.